So we're going to do a couple of videos that focus on things that are on the SATs but not necessarily covered so far or not emphasized a whole lot in our textbook. The first one is identities. And so you might ask, what is an identity? An identity is an equation that is true for all values of x. So let me give you a simple example. This is an identity. 3x is equal to 2x plus x, because what you can do is you can substitute any value you want in for x, and it makes it a true statement. X equals 1, yes, we can see it's true. X equals 2, also a true statement. In fact, any value of x that you want is going to leave this as a true statement. And maybe an easier way to do that than to try doing a whole lot of guessing and checking for x values would be to just simply rearrange the left or right-hand side of this equation so that it looks like the other. And in this case, you can do 2x plus x is equal to 3x. And now 3x is equal to 3x, and we can just visually see that 3x is, like, both of these sides are the same. So we can establish that, yes, it is an identity. Any value of x that you want to plug in to this equation is going to result in a true statement. And so that's what an identity is. And in fact, for the rest of this section, we're not going to do this guess and check. We're not going to plug in x equals 1, x equals 2, although that's really what it means, is defined that way as an identity. We are going to instead do the algebraic manipulation, and then as soon as we get the left-hand side is equal to the right-hand side, then we'll say, yes, it is an identity. Or if we're quite sure we can't get there, then we'll say, no, it is not. So, for example, here, we've got this x plus 1 squared. If you FOIL it out or use the identity formula that we have from back in chapter 1, we can see x squared plus 2x plus 1 is equal to x squared plus 2x plus 1, and that is an identity. Any value of x we plug in is going to result in a true statement. I'm going to pause right now and tell you that these next several videos are all going to be, the audio checks are going to be films that have won Academy Awards for Best Picture. And we'll start off with my favorite. I think it was like back in chapter 1, you already knew that my favorite movie was the Lord of the Rings trilogy. And so I'm just going to pause right here and say that it won more Academy Awards than any other movie, like even more than, say, the previous winner, which was Ben-Hur, and deservedly so, because there's some great movies. But that's what the audio check is today, Lord of the Rings trilogy. So here we've got this, and if you FOIL this out, then you can see that, boom, these two sides are equal to each other, and so therefore, yes, it is identity. I'm giving an example of something that's not an identity. Here, how do you prove that it's not an identity? Well, if you subtract 3x squared from both sides, and you get 5 is equal to negative 6, and that's a false statement, so no, it is not an identity. Let me tell you a little thing that I know about the SATs. One thing that they really have to do, and I don't fault them for this, because they have to really figure out, who knows their math and who doesn't, so to speak. What they really have to do is decontextualize skills. They have to give you problems that test you on a skill that you have learned in a way that you haven't seen before. An incredibly difficult thing to do. ACTs do this also. But basically, what they have to do is make you feel like you've never seen a skill before. They have to give you a problem that looks different, but still accesses the same information and the same skills and activates the same things that everyone's been taught. So one way that they do this is they first ask you to solve a normally recognizable problem, except they rewrite that problem with a variable where you'd normally expect a number to be. So, and then they'll give you some sort of ending condition that will help you back solve for that letter. So everyone and their mom, when they took Algebra 1, they had to graph something like y equals 3x plus 2. But the way they've turned it on their head a little bit is that they, instead of this 2, they insert an a. And then they ask you the question, what is the value of a if y equals 3x plus a passes through this particular point, 1, 5? And so it's just one way of turning things around and making them look a little different, even though you're really using the same skills. So what you realize is that in order for it to pass through this point, you've got to be able to plug in 1 here and get a 5 out. So therefore, if you do that, then you get a is equal to 2. All right, so that's decontextualizing of skills. They're not going to ask, is this an identity on the SATs? What they're really going to do is they're going to assume that it is an identity and then figure out what is the value of A. So the question will read something like, what is the value of A such that the below equation is true for all values of X? True for all values of X means it's an identity. So what you have to do is you have to manipulate the right or left-hand side until they basically look like each other, and then compare and see what would A have to equal in order for this to be identity. Well, when you distribute, you see that the 3's match up, but the A matches up with this. The AX matches up with the 3X, which are both the linear terms, and so then you get A is equal to 3. That's the answer. A would need to be 3 in order for this to be an identity. So the same thing here, slightly more complex. Mx squared plus nx plus a is equal to all that. Well, you can distribute, and you can FOIL, and you can distribute again, recombine like terms, and eventually you get this, 5x squared. So that would mean that m, if you were looking for m would have to be 5. If you were looking for n would be equal to 23. But I think what we're really doing is we're really looking for a. So why don't you take a look at this and this, and match up the constant terms, and tell me what would A have to equal. Here, this was what you might call an identity from chapter 1. We learned how to FOIL and how to, if you wanted to, the long way, if you didn't remember the formula, you could FOIL this out and get this answer. Or if you did remember the formula, it would be x cubed plus 3ax squared plus 3a squared x plus a cubed. In any case, what you can find out is that when you compare the left-hand side to the right-hand side, in order for them to be identical to each other and an identity overall, you have to make sure that comparing the linear terms, you have to get a cubed, which is going to be just, not the linear terms, the constant terms are a cubed plus c and c, so therefore they would have to be equal to each other. Bx is the linear term here, and 3a squared x is the linear term here, so therefore 3a squared has got to equal b in order for the linear terms to be identical to each other. And then 6x squared is the quadratic term, and that's got to have to equal 3ax squared. So lining up the coefficients, 3a has got to equal 6. And then moving from there, if you really just wanted to find a, then you could divide both sides by 3 and get a equals 2, and then use that information to find b and to find c. So that's what I have to say about identities. I'd like you to copy down the problem list for the assignment, which is the SAT assignment, and I'll do the first problem, and I'll see you in class.